All right. Welcome. Where we want to um, three of our exponential functions and the logarithms. Okay, so in this case, we're interested in um, all right, dealing with common and natural logarithms. Natural logarithms. Maybe let me write it nicely. We are talking about common and natural logarithm, natural logarithm. Okay, that's what we are talking about. All right. Now, from the onset, I must mention that the commonly used logarithmic function when functions have base 10 rather, have base 10. All right. And the natural logarithms okay, have base E. Okay. Now, also you may need to know that the natural logs, are mostly and commonly used in calculus. These are very important in calculus. All right, it makes our job easy. Okay. Now we can look at the definition now. Definition of common and natural logs. Okay, what is our definition? Natural logs. Okay. Number one, for the first definition, all right, we can say the function, all right, defined, function that is defined by f of x is equal to log 10 of x is called the common logarithmic function. Logarithmic function. That is what we mean by the common log of x. Okay. Now, that is, it is usually written, okay, written or expressed as f of x is equal to log. That is the natural, that is the common log. Then we talk about the natural log. Number 2, the function are defined by f of x is equal to log of x is a natural one. Is called the natural logarithmic function. Okay? That is, it is usually expressed as f of x is equal to the natural log of x. So that is what we mean when we talk about the natural log and the logarithmic function. Now, let's look at the properties of logarithm. Properties of logs. Okay? These are very important to deal with logs, exponential functions, logarithmic functions, okay, log equations. We need a property. Properties of logarithm. Again, I must mention that indices, the laws are handy in here. Now, we can say, suppose P is equal to B to the power M and Q is equal to B to the power N. Then we know that if we were to, this is an exponential form, but to express it in terms of log form or logarithmic form, what are we going to have? All right? We are going to have log, because our base is the B, so log B of P is equal to M. All right? And also, we say log this is the base here is B, so we'll have B here as our base. Okay, so we have B here. So we need to follow part 1, part 2, and come to part 3. So I've got B here, okay? O2 is equal to N. Okay? So that is what we have. Now, if I have PQ simply means my P is B to the power M by B to the power N. Now, by the rules of indices, if the bases are the same, we add the powers. This is same as B M plus C N. All right. Now, what does it mean? If I introduce logs, okay? So if I introduce log, our base, we express this in terms of our log. So we have B, log B of PQ. This is the same as, all right? This is the same as M plus N, all right? That's what we need. Okay? M plus N, and M plus N is log B of P plus, right, B of Q here, which takes us to the property, this property that if we have got log B of PQ is the same as log B of P plus log B of Q as the first property, this one, right? Hope that is fine. Note, however, that log B, P plus Q is not equal to log P plus log B of Q. They are not equal. These are not equal, right? Unless you are multiplying them, right? Number two, if I divide P by Q, this will give me, because P is B to the power M divided by B to the power N. Where are we getting this? From here, from this part, right? So this is the same as Bm minus Cn, all right? So it's like we have P over Q is equal to Bm minus N. This is an exponential form, so we can change to log form. So we have log B, all right? Of, we have PQ, P over Q, the answer is equal to M minus N. Okay. Okay. Now, so this takes us to this property that log B Q of P divided by Q is equal to M minus N. Now, what is M? M. M is log B of P. So we have log is the base B of P minus our N is log with the base P of Q. This is what we have. This is the second property. That is the second property. Also, there is a note that log B of P divided by log base P Q of course should not be mistaken to be equal to the log with base P of P minus the log with base P of Q. These are not the same. We go to the third property. Okay. Where we apply like x times n by m. This is x and m. Now we apply that in terms of log, right? And so now, suppose we have p to the power k, okay? Now we know that p is b to the power m. So we have b to the power m, but this is p, then there is k. So this will take us to b mk, okay? Okay, so what we have is pk is equal to b mk. So this is in like an exponential form, okay? If we want to convert it to logarithmic form, we are going to have log b, okay, of p being equal to mk, okay? That's what we are supposed to have, okay? Mk, which is the same as what? Km, okay? And this can be written as this is supposed to be k, our k, okay? So this is supposed to be written as we can drop the power, we can have k log b of p, okay? Which is equal to km, okay? And that km is equal to p to the power k. Now, what is our conclusion? Our conclusion is log b to the power k is the same as dropping k multiplied by log base of base b of p. This we need to remember. Okay. The fourth property we have maybe two special logarithms. Okay, which are also important. The first one, we can say for any base, b to the power 0 is equal to 1. For b itself must not be equal to 0. Okay? So, this is an exponential form. If we apply the logs both sides, we're going to have log, our base is b, okay, of 1. This is equal to 0. Okay? So, for example, log 3 of 1, I say the answer is 0. Log b of 1, the answer is 0. So, this we must remember as well. Then, the second property under special logarithms, they are saying for any base b to the power 1, all right, the answer is b. Now, if we apply the logs, we'll say log, our base is b, this is equal to 1. Then we have got, after the equal sign, there is b, so we have b here. So, implying therefore that log of base b, log b, which is the base of b, is 1. That is log base 3 of 3, the answer is 1. All right. Now, with these properties, we should be able now to answer different questions. Right? Answer different questions. Let's look at the question that I have. Use the properties of logarithms to expand the following. Logarithmic expressions. I assume that all variable expressions represent real numbers. Okay. A. A, what do we have for A? Log x y squared. Then B, ln T y divided by z squared. Okay. So we write our solution. So we have log of xy squared. Now, this implies that log xy squared is equal to log x times y squared. That's what it means. Right? So we are multiplying. All right. Actually, there's 5 here. Okay. There's 5 here. So in this case, 5. So this implies further that the log of base 5 xy squared is equal to, by the first property, since we are multiplying them, we are going to add. All right. So we are going to have log with base 5 of x plus log of base 5 of y squared. And this is your answer. Done. That's it. That's it. Then B, we have the natural log of e root square root of y divided by z squared. All right. Okay, so we can say this is the natural log if you want, you can even say let x be equal to e square root of y, and maybe I can even say alpha. All right, and beta is equal to z squared. So it simply means we have the natural log of alpha divided by beta. Okay, and we say this is the same as the natural log of alpha minus the natural log of beta. But now our alpha is, this is the natural log of e square root of y minus the natural log of z squared. Now, you realize that for this part again, we are multiplying. The same as the natural log of e times the square root of y. That's what we have. Minus the natural log of z squared. So now, by the first property, this will be the natural log of e plus natural log of square root of y minus, since there's a power, he drop the power, the natural log of z. Okay, the power disappears like that. Then we are going to say this is equal to the natural log of e plus natural log of the square root of y is the same as y the power half minus 2 natural log of 8. Okay, so this will give us the natural log of e plus, again, half will be dropped, natural log of y minus 2 natural log of z. But now the natural log of 1 plus half natural log of y minus 2 the natural log of 8. And this is our expression. So you can see that life becomes easy when all the properties have been done. Okay, this is where, and for part 3, look out for part 4 of exponential functions. This has been Mr. Piri. You can contact us on these numbers, right? You can contact us 0979673809. Contact Mr. Mbondo, right? Then you can also subscribe to our new channel, which we are promoting, right? For similar videos. Till next time, bye-bye.